this is an iHeart podcast. Guaranteed human.
With no fees or minimums on checking accounts, it's no wonder the Capital One bank guy is so passionate about banking with Capital One. If he were here, he wouldn't just tell you about no fees or minimums. He'd also talk about how most Capital One cafes are open 7 days a week to assist with your banking needs. Yep, even on weekends. It's pretty much all he talks about, in a good way. What's in your wallet? Terms apply. See CapitalOne.com/bank. Capital One, N.A., member FDIC.
Tax season has arrived, and doing taxes without the right help can feel overwhelming. Intuit TurboTax is here now to guide you through it with confidence. Match with a TurboTax full-service expert who handles everything for you from start to finish. Your dedicated expert checks every single deduction and credit to help you get the best possible outcome so you can feel confident you're getting every dollar you deserve. And the best part? You'll see real-time updates on your expert's progress right on your phone while you live your life. Plus, you get unlimited expert help at no extra cost, even on nights and weekends during tax season. Visit TurboTax.com. Only available with TurboTax full-service experts. Real-time updates only on iOS mobile app.
Brought to you by the reinvented 2012 Camry. It's ready. Are you? Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark. With me, as always, is Charles W. Chuckers Bryant, son of Mrs. Bryant.
Yeah,
Yeah,
she kept the name.
good for her. I like your mom.
Yeah, have you met my mom?
Yeah, I met your mom at the Love Your Mama
Oh, yeah.
opening, appropriately enough.
That's right.
Yeah.
I thought you said your name was Josh Quark for a second there.
If that was off the cuff, I'll accept that.
I did. I just made that up.
That was great.
It is not written down anywhere.
That is great. Chuck said that because we're going to be talking about quantum physics today. And quarks are, it's my understanding, Chuck, that they're the fundamental basis of matter.
Yeah, they make up hadrons, which you may know that because we talked about the Large Hadron Collider.
Yeah, up until about like 30 seconds ago, I didn't know why it was called the Large Hadron Collider.
Yeah, well, there's 6 quarks, Josh. They are known as flavors, which is kind of cool.
It is cool.
Up, down, charm, strange, top, and bottom. And apparently, charm, strange, top, and bottom, you can only be produced with like a big collision, like the Hadron Collider.
Okay.
The
Like
up and
a
down.
Large Hadron Collider, huh?
Yeah.
Yeah.
And there's also anti-quark, too, which is like the opposite.
Yeah, those are the quarks that smoke cigarettes and wear leather jackets.
Exactly.
Chuck, quarks exist they're particles, they're matter, right? They're the building blocks of matter?
That's what I understand.
So they exist on the subatomic level, smaller than atoms, or below atom, depending on, how you like the word sub.
Yes.
And they exist in this weird world, the quantum world. Mm-hmm. They bump elbows against photons, which are my favorite subatomic, particles.
Okay.
And plenty of other weird, strange. It's like this odd parade of physical things, right?
I don't like it there.
I can understand why you don't, because it's a very disconcerting
It is.
and uncomfortable world. The very comforting ideals and principles of Newtonian physics,
Yeah.
which are what goes up must come down.
Reality.
The sun's going to rise tomorrow,
Yep.
depending on whether or not you're a Robert Hume adherent,
Sure.
David Hume adherent. Just these things that we can depend on. We've come to depend on since Isaac Newton,
Yeah.
had, his breakthroughs.
Sure. I learned a lot about myself reading this, actually.
Did you learn that you get angry easily?
No, it just like the whole notion of like stepping outside reality disturbed me.
Yes, and what's even more disturbing is that this universe is envisioned by some very, very smart people.
Yeah. Or I should say what I perceive as reality, by the way. I just want to clear that up.
Nice.
Okay.
So, Chuck, we've done one on the Large Hadron Collider, right?
Yep.
And this is
hated
just
that
like,
one too.
This is just like this huge, fancy, multi-billion-dollar machine that's new, that's still going.
Yeah.
Right? Back in the 90s, they didn't have these Large Hadron Colliders to, rely on to actually see and measure and detect things on the quantum world, they had to use their imaginations. Physicists did.
Uh-huh.
And specifically in 1997, there was a physicist who used his imagination for what's called a thought experiment. Where you
I do like that idea.
Yeah. This guy's name is Max Tegmark, and he is awesome. He was at Princeton at the time. Now I think he's at MIT.
Smart guy.
And he came up with a thought experiment called quantum suicide. Mm-hmm. And will you allow me to explain it as follows?
Please do.
Okay. So you are a guy, and you're sitting in a room, and there's a gun pointed at you, at your head.
I don't like where this is headed.
A kill shot.
Yeah.
You're looking at the barrel, right?
Uh-huh.
And the gun's a little off. I mean, it's a normal gun, but it's hooked up to this newfangled machine, right? And this machine is set so that it measures a quark. It measures the spin of a quark, right?
Right.
So let's just say, for simplicity's sake, although you've already said this isn't true, let's just say that a quark can only spin clockwise or counterclockwise.
Okay.
Okay? This machine is set so that every time the person sitting in front of the gun presses a button, the quark is measured. Mm-hmm. If the quark is measured with a clockwise spin, the gun's not going to go off. There'll just be a click. Okay?
Right.
If when the guy presses the button, the quark is measured and it comes up with a counterclockwise spin, the gun's going to go off. The trigger will be pulled.
Yes.
The bullet will exit the chamber. It will travel several feet across the room into the head of the man sitting in front of the gun, and he will die. Guaranteed death, like it's a kill shot, okay? Sure. What's weird is that in this quantum suicide thought experiment, Max Tegmark figured out that if this guy pressed the button every single time, he's going to hear a click. Click, 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 click. No matter how many times he presses it, no matter how long he tries this,
right,
all he'll be aware of is this clicking of the gun.
Because he lives.
Yes. He lives in every single scenario.
Right.
How can that possibly be? Well, let's go back to the beginning. That first time the guy pressed the button, okay?
Yes.
What happened in another parallel universe is the gun went off and he died.
Right.
Okay? So with that first experiment, the universe split into two.
Yep.
One where the gun went off and he died. One where he just heard a click.
Right.
Now, if we follow the one where he heard the click,
that's all
every
he knows.
time he presses that button and the quark is measured,
right,
the universe splits into two. But he's only aware of the one where he just hears a click because
that's his reality.
The one where he's alive.
And if he died, he clearly wouldn't understand that because he'd be dead.
Yes.
So part one of Mind Meld just started, I think.
That's the quantum suicide thought experiment.
Yeah, I like it.
Yeah, it's pretty mind-boggling, right?
Absolutely.
And it's used to, it's pretty exemplary of the kind of goofy, like you said, mind-melting ideas that are brought up on to explain quantum physics, right?
Yeah, which you have to do. You have to use thought experiments because you can't use it's unpredictable at that level, so you can't use like a regular scientific method.
Right, and one of the reasons why it's unpredictable is because when you look at, say, a quark, if a quark only had a spin of clockwise or counterclockwise, quantum physicists have found that when you observe a quark, one time you'll observe it and it's spinning clockwise. The next time you'll observe it, it's spinning counterclockwise.
Yeah.
Or, even more unsettlingly, they found that photons, these smallest packets of light, you can look at a single photon at one point or measure it, and it's a particle. You can measure it the next time, the same photon, and it's a wave. So this is kind of like somebody running, walking, and swimming at the same time.
In different directions.
Right.
Crazy.
Like you said, it's uncomfortable what they're finding on the quantum level.
So what you got, Josh, is a chaotic situation. And that's sort of how it exists now, but as you pointed out, you wrote this, I should point out. And this is a performer. This one has done really well, right?
Yeah.
You should tout yourself.
Yeah.
But sometimes scientists think that the more we learn, that some order will fall into place on the quantum level at some point.
Well, hopefully, yeah.
Hopefully, or else it's just going to be theory after theory.
Either that, or else, it's like the laws of physics the laws of Newtonian physics just don't apply on a certain level.
Right.
Down to they just apply on this specified level.
Sure.
One of the fundamental tenets that has long been debated is the idea of Heisenberg's uncertainty principle, right?
Yeah.
So one of the things, like early on in quantum physics in like the 20s, there were a lot of guys who were trying to explain why these weird things were showing up, right?
Well, inconsistent at least.
Right.
Yeah.
And one of the early guys, one of the early physicists was Werner Heisenberg.
Yeah, Mexican, wasn't he?
Yeah.
Werner Heisenberg.
And he came up with this explanation, or this, I guess he pointed out like a major flaw with quantum mechanics is that when we observe something, just the act of observing something, we influence its behavior, right?
Yeah. This is where I started to get a little hinky with this. I understand it in concept, like even like shining a light on something that small will cause it to change, but it gets a little more like philosophical than that.
Well, yeah.
Like simply looking at something will affect the outcome.
That's a really great point, Chuck. There's the quantum physics has a lot of philosophy and logic tied into math.
Mm-hmm.
It's not just straight up math.
Yeah.
There's philosophy to it, right?
Sort of appeals to me on that level, but it doesn't make it easier to understand for me.
Well, this is how Heisenberg's uncertainty principle was explained to me once. Let's say you're blind, and you have this ball, a heavy ball that has a lot of bounce to it, that you've learned to basically see with. You know how a bat uses sonar?
Yeah, to bounce back the wave to find out how far they are from something, sure.
Right. Let's say you've learned to kind of do the same thing but with the ball, right?
Okay.
And you know that there's a chair across the room and you want to figure out roughly how far away the chair is. So you throw your ball at the chair and you manage to hit it, and the ball takes a second and a half to come back to you.
Sure.
And after being pretty good at this by now, you know that the chair's about 30 feet away. That's how long it takes for something for the ball to get back to you in a second and a half with about as hard as you threw it, right? What you've just figured out is the position of the chair, or where the chair was when you threw the ball at it.
Right.
What the problem is you've just influenced the behavior of the chair. You just threw a ball against it, so you sent it careening off into space, and now you have no idea where it is.
Yeah, I get that. I get the ball moving the chair. What I don't get is looking at something.
Well, on this level, consider this.
Okay.
With photons, remember the smallest packet of light, my favorite quantum particle?
Sure.
There is a nanomachine, it's a motor, right? And it's operated by shooting light at it. So these packets of light that have no mass and no charge,
right?
The particles we're talking about are so small that a photon, a little packet of light, can actually influence them. So we use light to see, say.
Right.
Let's say and this is a very basic elementary explanation, but we use light to see. Mm-hmm. If we have the light on, there's photons just bombarding something, right?
Right.
So if a photon can hit a particle, we know where its position was when we turned the light on, but we don't know where it is now because the photon just sent it careening elsewhere.
Right, which delves back a little bit into the philosophical. Like you walk into a dark room and you don't know where the chair is until you turn the light off, but did the light move the chair?
Right. That's exactly right.
Right.
That's what smart people have to say about quantum mechanics.
No wonder I don't get it. Oh, okay. I got it.
But you do get it because you just explained it perfectly.
No, I get it. I was just kidding.
Right? Okay. All right. So that's Heisenberg's uncertainty principle, and that's been something that's kind of provided a conundrum for quantum physicists, and not everybody's bought into that, right?
Well, and that's why they had to dream up the thought experiment to begin with.
Right. Okay. So if just observing a particle means we affect its behavior, well, then maybe we should use thought experiments, especially pre-Large Hadron Collider physicists. This is their thought process, right? Mm-hmm. So this is why Tegmark came up with the quantum suicide thought experiment. But he didn't. He came up with the thought experiment to prove another quantum theory called the many worlds interpretation.
Yeah, Hugh Everett, fellow Princetonian, in 1957, and I know he was stoked, because 40 years, people were kind of like, I don't know about this many worlds thing.
Yeah.
Until your guy came along.
Yeah.
I call him your guy.
Well, I've actually chatted with him. He's a good guy.
Oh, that's right.
Yeah.
You did, didn't you?
And he provided a picture.
It was like 40 years, right?
Yeah, 1957 and 97.
Exactly 40 years then. And it supports quantum suicide. The many worlds theory is for each outcome, each possible outcome to an action, the world copies itself. It splits into a copy of itself.
Right, and it's simultaneous, and we have absolutely no power over it whatsoever.
Yeah.
It's a process called decohesion.
Right.
So, Chuck, this universe that we're in right now is going along smoothly because there's no choice or option, right?
Right.
But let's say I'm deciding whether or not to take a sip of this coffee or not. Just making that decision, I didn't just now, but there was decohesion when I made that decision not to.
Right.
Because in another universe, another parallel universe now exists where I did take a sip of that coffee.
Well, yeah, and the key here is that you don't know that this other universe has been created.
No, because and you want to imagine that you can look over to your right somewhere,
right,
and you see yourself drinking the coffee,
right.
But you can't. We're not cognizant of that universe. It's branched off. They're no longer cohesive.
Right.
Right.
And that supports the quantum suicide thought experiment perfectly.
Well, that's what Hugh Everett came up with to explain why a particle, a photon, could be both a wave and a particle. Right.
Right.
The unsettling part of this is, with Heisenberg's uncertainty principle, we're in charge. We look at a quantum particle and we affect it, right?
Oh, wait, that was with whose? Heisenberg?
Heisenberg's uncertainty principle. With the many worlds interpretation, we're just observers, right?
Yeah, parallel universes happening all over the place.
So let's say that let's say I was the guy who decided I wanted to find out if there was such a thing as quantum immortality, that I could just sit there with the gun and actually carry out this thought experiment and see, right?
Yeah.
And consider this. It's entirely possible that if somebody did do this, they could live forever, and only they would know.
Right.
You know why? Because as an observer under the many worlds interpretation, you're just along for the ride, right?
You sort of have to accept that, don't you? If you support this theory.
Well, yeah.
Yeah.
That's the basis of it, right?
Sure.
So let's say that I was the guy who sat down in front of this gun and started pressing the button, right?
Yes.
And you're sitting there watching me, maybe drinking a root beer.
Waiting for that fire.
Yeah. Eventually it would happen because you're not doing anything. You're not making a decision. I'm making the decision. You're an observer, a bystander to my decision of pressing that button, right?
Isn't that where predictability comes in?
Probability. So eventually, just based on the chances of a coin toss, you're going to be witness to that cork being measured running counterclockwise and the gun going off and me dying.
I don't want to see that.
And after that, the universe can't possibly split anymore because you're not making the decision. I'm making the decision to press the button. While I'm dead, I can't make the decision to press the button anymore, so then the universe has stopped splitting for you.
Right.
So that's pretty unsettling because we have no control whatsoever over anything.
Oh, yeah.
I mean, if I would chalk it up to free will whether or not I'm taking a sip of that coffee. But free will doesn't exist if the universe is splitting into two to accommodate every possible outcome. And just imagine it splitting into more than two. What if there's more than one outcome for a decision?
Like many worlds.
Okay, right. So this is the many worlds interpretation. And that's how quantum suicide basically proves it by saying if somebody sat down and did this, they would become immortal. It shows that the many worlds interpretation is theoretically possible, which is what it seeks to do, right?
Right, and that's sort of the new kid on the block, right, when it comes to explaining this.
Yes.
Not like the Copenhagen interpretation.
Yeah, well, let's take it. Let's take it, Chuck.
Well, that's the one that's been accepted and still is in a lot of circles, but the one that had been accepted for like the last century, basically.
Yeah.
And you pointed out, too, that this whole thing is really only about a century old or so.
Yeah, I believe it was Max Planck in 1900 who
Which
first
is new.
Basically founded the field of quantum physics.
Yeah, which is very new on on that scale.
Newton came up with his stuff in the 18th century, so this is I guess the newest field of physics.
Right. So the Copenhagen interpretation, Josh, is Niels Bohr in the 1920s, or actually in 1920.
Right.
And it says that a quantum particle doesn't exist in one or another, but it exists in all states all at the same time.
Right, and the state of existing in all possible states at once is called a coherent superposition, or just superposition, right?
Right, and the total of all those is the wave function.
Right, so remember I said this is like running, walking, and swimming all at the same time?
Right.
So the state of running, walking, and swimming all at the same time is called a superposition, and then being able to run, walk, and swim as possible states, that's the wave function.
That makes you an Iron Man.
It does, but it makes you like the optimal Iron Man, doesn't it? Right? You just finish the race immediately.
Yeah, everyone else is finished with the running part, and you're like dripping wet with your bike on your shoulder.
Right.
Nice.
Yeah.
So Bohr, he proved this. This whole Schrodinger's cat thing. This is a little funny. And Schrodinger supposedly designed this to sort of show how silly it was, right?
He did, but at the same time, he was also, he was a serious quantum physicist, and he was a huge rival of Heisenberg, actually. And Heisenberg said Schrodinger's ideas were crap.
Oh, really?
Yeah.
Is that the word he used?
Yes, and
Nice.
And I can't remember what Schrodinger had to say about Heisenberg's uncertainty principle, but they didn't like each other.
All right, so Schrodinger's box. Can I describe this?
Yeah, and if you didn't get this is to the Copenhagen interpretation what quantum suicide is to the many worlds interpretation. It's a thought experiment designed to theoretically prove that it's possible. Okay?
People are like, can't you just talk about ticks being on your nether regions? So much easier. All right, Schrodinger's cat, and this is, I should point out, this is a theoretical experiment. He didn't really do this.
Right. But
Right?
he could.
Well, he could have. So what he did was he got a box that you can't see into, which is very key, as you'll find out. He put a cat in there, theoretically. He put some radioactive material in there, and then he put a Geiger counter in there, and like a little device that would, if the radioactive material leaks out, it would smash this poison in there, and it would kill the cat.
Right. If the Geiger counter sensed radioactive decay,
Right.
it would trigger this hammer that smashes the poison vial, killing the cat.
Right. But that's just a clever way of setting this up. It's really not important what he did.
Oh, I like being clever.
Well, no, it was very good.
Thank you.
But the point is, he did it within like an hour or so where it's still possible, like the cat didn't starve to death.
Right.
The cat could either be alive or the cat could be dead. You don't know because the cat is sealed inside this box. Mm-hmm. So in theory, the cat is both alive and dead.
Right, and the other part about that hour is that he determined, say, like over an hour, there was a 50-50 chance that the radioactive material would decay or wouldn't decay. So the Geiger counter had a 50-50 chance of detecting it.
And this is where I have a big problem with all this stuff.
Yeah?
Well, it's like you pointed out in the article, too, and that's what made me think of it. The tree falling in the woods, would you really hear it? Mm-hmm. I've hated that since I was a little kid. I think it has to do with how your brain is wired.
Yeah.
Because whether or not the cat is alive or dead, just because you don't know the answer doesn't mean it's both.
Well,
that's to me as an English major musician type.
Right. In this though, so the cat being alive or the cat being dead, right? That's its wave function. Those are the possible outcomes.
Right.
And since the box is sealed off, like you said, it's very important. You can't see in it. Mm-hmm. You can't detect anything in it.
Right.
The cat's in a superposition of both life and death.
Yeah.
The point is what Schrodinger was saying in this and how it supports the Copenhagen interpretation and is actually more like the Heisenberg's uncertainty principle than Schrodinger would have liked to admit.
Right.
We, the observer, force the outcome. Okay?
By observing it.
We open up the box and the cat's either alive and we see that the cat's alive.
Right.
Or we open up the box and the cat's dead and we see the cat's dead. The point of Niels Bohr's Copenhagen interpretation is, so these things exist in their superposition.
Right.
And when we observe them, we force them into basically a choice. We collapse their wave function, or we collapse their superposition, and now they're a live cat or it's a dead cat. But it's because we observed. And until we observe, they're in this state of all states at once.
That's just where and like I said, it's got to have something to do with your brain, because my brother was a big math guy.
Right.
And he used to tutor me some, and he could never understand how I didn't get math. Just like I don't understand how they get physics on that level, but I don't understand how someone can't sing on key. Because to me, you hear the note and you just replicate it.
You know what I understand?
What?
What a brain cramp feels like.
Yeah, right now.
Yeah.
Whew.
So Chuck, again, the great thing, the comforting thing, the thing that allows me to sleep at night about Bohr's
aside from
theory,
Valium,
in Scotch,
sure.
The part about Bohr's theory that is comforting is that, again, it's up to us, right? Things we can't look at a cat and see it in a state of life and death simultaneously.
Right.
We force things to happen, and at the very least, things make sense to us in that way.
Yeah.
Right? With the many worlds, again, we have nothing to do with it. It just happens on its own. Decohesion happens like instantaneously whenever there's a decision made by a conscious being. And even worse, so time's not linear.
Right.
It exists in like these jumps and starts and branches.
Right.
And so for every decision ever made by any conscious entity, that includes rabbits, Chuck. Right?
Yeah.
That the universe is split into every possible outcome.
It's like Lost.
Oh, it is, and it's the basis of not just Lost, but like a lot of other. There've been a lot of other works. What was that one, Third Contact, you sent me? It looked like a student film or something like that.
Yeah, there's some pretty cool little short films though.
Yeah, there's just because it's so mind-boggling. And the great thing is that quantum physicists seem to have like a little bit of a sense of humor. Or at the very least, they're well aware that what they're saying is just completely nuts.
Right,
they're like, hey, don't kill the messenger. We're just trying to figure out what the hell is going on here.
Right.
Schrodinger called his cat experiment quite ridiculous.
Yeah.
And Niels Bohr had a great, great quote, didn't he, Chuck?
Yes, Josh. He said that anyone who is not shocked by quantum theory has not understood it.
Right.
That says it all.
All right. It does say it all. And I think also what it did was it bought quantum physicists some time.
Right.
Yeah, it's like, you go figure this out.
Right.
Well, we really go figure this out.
Well,
we'll come and explain it to you.
You got a little clever there on the last page, which I appreciated when you said that, there are all these different theories, and when you're talking about quantum physics, and a lot of them contradict each other, and maybe if you believe in this kind of quantum stuff, maybe they're all right.
Right. Yeah.
Yeah. Maybe the ones that contradict each other, they're both right depending on what universe you're in. So
depends. If you're a many worlds interpretation devotee, then yeah, that would be
so quantum.
Yes, super quantum.
That's so Raven.
We should be wearing Tron outfits right now.
Oh, I saw that trailer the other day, man, before Inception.
Oh. Yeah.
Looks really good.
Yeah. Although I gotta say, I liked Inception, but it could have been better.
I enjoyed it.
I did too.
Christopher Nolan can direct and write the crud out of a movie.
Yeah, but how much of it, though, is that no one else is making anything even remotely watchable?
Yeah. You're right. Wow. He came along in a good time, didn't he?
Yeah, he did. So that's Quantum Suicide.
I can't wait to see the listener mail on this, man. When these physics guys write in,
yeah.
it's and I'm not making fun of them. I mean, it's really enlightening. They take it really seriously.
Oh, sure.
It's awesome.
Yeah. And don't forget, Chuck, we met somebody in New York at the Knitting Factory, I believe, who is a quantum physicist who explained to us like how we screwed up the Large Hadron Collider.
Yeah.
So if you're out there, I can't remember your name. Remind us.
Was that the Hadron, the Collider?
Yeah.
Dude?
No.
Okay.
No, those are they're a comedy troupe.
Oh, much different.
Hadron the Collider. Yeah. They have a podcast. Check it out. I guess now what? It's time for listener mail. Do you have something?
I do.
All right. It's time for listener mail.
Josh, I'm going to call this Cool Kiva Wedding.
Okay, can I throw something in first?
Please.
There's something we've overlooked too many episodes have gone by, in my opinion, but we need to put this out there. Remember Sean from Virginia Beach, the cubicle guy?
Yeah.
Who just was like, I've listened to everything, and there was no origin of Hippie Rob.
Right.
Well, we put the call out for everybody to let us know where Hippie Rob first appeared and in what capacity, and we got a great response.
Oh, yeah.
First one to write in was Emmy. Thanks for writing in, Emmy, but thanks for everybody for writing in. If you go back and listen to how squatting works and listen to approximately the 2:50 mark, 2-minute 50-second mark, you will find the origin of Hippie Rob.
Yeah.
And if you want to show up, he also shows up at about the same place in the Earthquake podcast, too. And elsewhere, but those are the two largest chunks of the Hippie Rob saga.
He's peppered throughout. Isn't it funny that this dude is just out there existing somewhere and has no idea? It's like in another parallel universe.
Exactly. Wow.
You're welcome, Josh. This is from Jana in Minnesota, and she says, Josh and Chuck, I'm a huge fan of the show. I wanted to share a story with you. My husband and I recently got married June 19th, 2010, so mazel tov to that.
Yeah.
You know, at the reception when people ding the glass to make newlyweds kiss,
Mm-hmm.
I'm not sure if it's a tradition in Georgia or not. It sort of is.
I think it is.
We didn't do that.
Yeah.
We had paper cups. No one heard it.
Did you really?
No.
Oh, okay.
We did have a budget wedding, but we didn't have paper cups.
Plastic.
We had PBR in a bottle.
That's very classy.
Thank you. Everyone else starts to also ding their glass, and then you have to stop eating and kiss. My husband and I didn't like that idea. I don't either. Something about the annoying clanging sound didn't sound like fun.
Plus, it's really demanding.
Yeah, you can't make me kiss. That's what I would have said. I would have got all obstinate at my own wedding. So we decided that people had to put money in a jar to make us kiss. Great idea.
Yeah.
All the money placed in our jar would be donated to Kiva
Fantastic.
through the Stuff You Should Know
The microlending site.
team, the microlending site. You
So
know, we've
the
also
socially responsible microlending site.
yeah, we should also spell that because we get called out because it's such a weird word. It is KIVA.org.
Yeah. And then /team/stuff you should know.
Yeah, if you want to donate for our team.
Yeah.
So she said it wasn't the biggest fundraiser of all time or anything. They made about $50 in kisses, and they were happy to donate. So that's 2 loans right there. And I just thought it was cool that we've been included now in someone's wedding day and wedding night. If you remember that other one. And, I'm just, I guess I'm waiting on us to cause a divorce. That would bring this full circle.
Yeah. I know we helped somebody through a divorce, didn't we? Didn't we get an email from somebody who was getting divorced?
I don't know. Maybe.
I think we have. And thank you. Who was that?
That was Jana from Minnesota.
Thanks, Jana and husband. Congratulations on your wedding. And if Chuck and I have hastened the end of your wedding or have been present at the birth of your kid or whatever, any major life event, we want to hear about it. Send us an email to stuffpodcast@howstuffworks.com.
For more on this and thousands of other topics, visit howstuffworks.com. Want more How Stuff Works? Check out our blogs on the howstuffworks.com homepage. Brought to you by the reinvented 2012 Camry. It's ready. Are you?
The NFL playoffs are here, and Wild Card Weekend powered by Verizon is in full swing.
Man, it all comes down to this.
The stakes are high, hopes are higher, and everything is on the line.
My goodness!
It's win or go home, and every moment counts on the road to Super Bowl 60.
It's a touchdown!
Wild Card Weekend powered by Verizon. Through Monday. Visit watch.nfl.com for the full schedule.
You know, Donald, I just want to scream out into this canyon and tell the whole world T-Mobile's got home internet.
Do it, Zach.
T-Mobile's got home internet!
Let me try. T-Mobile's got home internet.
How much is it?
Just $35 a month, and it's guaranteed for 5 years.
I'm switching.
Me too.
T-Mobile's got home internet. Just $35 a month with auto pay and any voice line. And it's guaranteed for 5 years.
Taxes and fees apply. See T-Mobile.com/ISP for details and exclusions.
This is an iHeart podcast. Guaranteed Human.